So let us see one more question of 2012 paper. See, let us read the question. Orthonitrophenol is more acidic than orthomethoxyphenol. This is what is the question given. So I have to speak in terms of acidic nature, right? So first, as soon as such question is given to you, write the structures of both, right? So first they've given me orthonitrophenol. So this is your phenol, right? OH. At the ortho position, there is a nitro group. Nitro group is NO2. That this is done. So next is orthomethoxyphenol. So you're going to write your phenol ring, methoxy, right? Your methyl group and oxygen. So this is orthomethoxyphenol, orthonitrophenol. Then they said this is more acidic than this particular. Now let us see. So what is the difference between this group and this group? First of all, basically when I see OH, right, it is, so what is OH? OH, your NO2, correct? Let us come back here. OH and your OCH3, CH3 rather. Your OH, when I see, it is an electron releasing group. Nucleophile, correct? So what type of effect is it showing? It is showing plus I effect. And when I speak about NO2, NO2 is electron withdrawing group. It's going to drag the electron density. So it's going to show us minus I effect. Now, again OH, plus I effect. And thus again methyl group, fine. So when I speak about methyl group specifically, this also shows it keeps on releasing electrons, electron releasing group. Yeah, now what happens when I see this factor? Basically when NO2 is an electron withdrawing group, what is the difference you're finding? First important thing, this is going to drag the electron density from here. When it's dragging the electron density from here, it's easy for me to cleave the bond, correct? It can easily break the bond. So NO2, first you're going to write NO2 is electron withdrawing group. Yes. So what happens? There is a cleavage of the bond, or it's easy to break the bond. Because of this nature, the electron density is completely dragged towards NO2. So electron density decreases around oxygen. Yes, this is going to happen. When electron density decreases around oxygen, it's easy. Then once this is decreasing, immediately release of H plus becomes easy. When something is releasing H plus easily, that means it is highly acidic. So it is highly acidic. Right, this is your first reason what you're going to write. Yes, so nitro group is electron withdrawing. It's going to drag the electron density, and the bond between both of them first cleaves. Once it cleaves, your H plus is easily released. Hence, it is more acidic in nature. This is your first reason. So once I read, if I have to write the second methyl group. So what is the second methyl group? I have to write here. Your CH3 is electron releasing group. Correct? Yes. Now what happens to the electron density? This also releases. Your electron density around oxygen increases. Now release of H plus, because of this releasing nature, release of H plus becomes difficult, because already you have lot of electrons surrounding the OH oxygen, so it will not pull up or it will not release that H plus. Now because of this, it becomes less acidic in nature. So this is dragging, releasing H plus, this is releasing electrons. So proton, it's very difficult for me to break that proton and show that acidic nature. So this is your first reason for writing the acidity. After writing this acidity, the next important reason which you are going to write is based on very important factor called, just observe, this particular nitro, yeah, I said it's going to break the bond, it's going to pull up the electron density. When this is breaking, it's going to form, what does this look like? Now this has almost cleaved or pulled the electron density. There's a cleavage of bond, this breaks up and it becomes H plus is released out, and your oxygen and your bonds and your NO2 and double bond O and your O minus. Looks like this, correct? Now this is your minus. Now how many oxygens now? Or how many alone pair of electrons? 1, 2, 3, 4, 5, 6, 7, 8. Correct? Now how many for this? 1, 2, 4, 5, 6, 7, 8. How many for this? 1, 2, 3, 4, 5, 6. Yes, this is your nitro group. Now what is this compound? This compound or this is called phenoxide ion, right? Phenoxide ion or along with the nitro group. Fine. Now this phenoxide ion, what is it now? It has released out H plus. So what is this group? This is a conjugate base. This is a conjugate base. Observe, I'm giving you the second reason. Now this O minus is a conjugate base of your phenol. Always remember, whenever you have this O minus, and what does it do? It's going to show, now I said it is a conjugate base, done. The concept is, if the conjugate base is highly stabilized. Now observe, if the conjugate base is highly stabilized, it is, the compound is higher is the acidity. Higher is the acidity. So what am I writing now? I'm writing a new word now. Always what do you say? Higher is the acidity. So I just now said this phenoxide is a conjugate base of phenol. Correct? Now how much ever you stabilize that conjugate base, the acidity increases to that extent. Maximum is that acidity. So what does this group do? Remember this is very important. So now what does this phenoxide do? It's going to show us resonance. How does this look now? It's going to show us resonance in this way. Just observe, oxygen is going to drop in this electron pair. So how does this look now? This becomes a double bond oxygen. How many are there? 1, 2, 3, 4. 1, 2, 3, 4. Correct? Yes. Now your double and double can't be together. So this is going to shift here. Now this bond broken. So you will get a double bond nitrogen. Now double and double bond can't be together. So this is going to shift here. So how does this look? This is oxygen. Yeah. So 1, 2, 3, 4, 5, 6, 7, 8 minus. And other side you also have, now this is your plus, right? When this is minus, this is your plus. Now this is your plus like this, your oxygen. 1, 2, 3, 4, 5, 6, 7, 8 minus. Now this is how it's going to show us the resonance. Yes, so phenoxide, from phenol you have got phenoxide ion. Phenoxide ion is a conjugate base. We very well know if a conjugate base is stabilized. How is it stabilizing? By the concept of resonance. It's going to stabilize by the concept of resonance. So more the number of resonating structures, higher is its acidity. It's going to stabilize, show the resonating structures, and finally it's going to undergo stabilization factor. It's going to get that stabilization factor. So what are you going to write? The first reason, minus I effect of nitro group, point number 1. Second, formation of conjugate base, and conjugate base is stabilized by resonance. So if resonance is more or resonating structures are more, it is highly acidic in nature. So this is the second reason for this. So this will be your reason 2. So let me summarize into first thing. So what do you say? Orthonitrophenol is highly acidic. Why is it? First thing, due to minus I effect, electron withdrawing nature, and due to formation of conjugate base, and conjugate base is stabilized due to resonance. So I said conjugate base, you can add this point. The conjugate base, higher the stability, more is acidity, and you can finish this. Now I have to write in terms of what? Methoxy, orthomethoxy. So in orthomethoxy, so what are you going to write? Orthonitrophenol? No, orthomethoxyphenol. So in orthomethocyanol, what is observed? First thing, here you have written plus I effect, electron releasing effect. Yes, no resonance observed. No resonance observed. Hence, less acidic. This is how you're going to write your complete answer. You'll be getting complete full mark for this.